Good morning, my dear kids. In today's class, in the chapter Ray Optics, we are going to discuss the topic the problems, numericals on the refraction at plane surface. So, if you can recollect, the previous class we had the slabs double refraction, and we focused only on the slabs. Like if a slab is brought nearby a mirror, silvered slab, all that were related. It was a double refraction. So today we'll explore a few more problems on the refraction. Okay, let me start the class. Okay, kids, like we have even the website also, www.physicsnumericals.com, and we have the app. Please share the app to all your friends who may need this. It's a free app and free website. We are not charging anything. Hmm. So, and it's all about the JEE mains and advanced. The best of the best content is available in front of you. So not only you are taking help of it, please do spread information of this app and the web to all your fellow students, fellow friends. They'll get benefited. It's not that like something this app that when you go to the college, normal college, there take coaching. Any of the things which you find very difficult, you can settle it with the help of my app. Or else, if you are unable to afford the coaching, so the best content is I am providing you. Hmm? So this will help you to get the best ranks also very easily, provided if you put effort. Hmm? So please share the information of the app and website to all your friends. Hmm? Okay, we'll start our class. Okay, you have to find the number of images and positions of fish as seen by bird, bird as seen by fish. The bottom of container is silver. So I do have here bird. I do have a bird which is at a height A, and the fish is at a depth B minus C or at a height C from the bottom. This bottom is silvered. This part is what? Silvered here. So the silvered surface will behave like a mirror. We have bird is in air, fish is in water at a depth B minus C, and this is a boundary. Now, how many images the bird will see that of fish, and what about their positions? So that was the question is all about. Okay, first what happened? The fish as seen by bird directly, the first option. Fish as seen by bird directly. So at what is the distance at which the bird is from the boundary? At a distance A. The fish is what is the depth, the real depth of the fish? B minus C. Then the apparent depth will go B minus C by mu. So therefore, the first case, this will be, I'll write some S1. So some distance, A plus B minus C by mu. What is A? Distance of the bird from the boundary. What is B minus C? Depth of the fish, real depth. This is the apparent depth, B minus C by mu. Now fish as seen by bird indirectly. Fish as seen by the bird indirectly. Indirectly means first the rays emitted by the fish. Initially here, what is the basic diagram? The diagram is like this. Rays emitted by fish. This was that one. Initially this one. So now next part is like first the mirror, the rays emitted by the fish will strike the mirror, will form the image. Then the reflected rays from the mirror will undergo refraction, will enter into bird's eye. We will draw the diagram. We'll draw the diagram. This is a mirror. So this is a fish. So the rays, and this is the silver part. Okay, this is the so rays emitted by it will undergo reflection. So the rays will, okay, this is F dash you call. These rays now will enter into bird. So this is distance is how much? B, and this distance is what? A. No? So the rays emitted by the fish first will strike the mirror. This is the mirror. Huh? Hope everyone is able to understand. Hmm? The rays emitted by fish will strike the mirror and image will be formed. So what is the distance will be C. Then this reflected rays will undergo refraction. This will enter into the bird's eye. These rays, enter into bird's eye. So what is the distance of F dash? F dash will be B plus C. So what is the distance now at which it will be? Fish as seen by bird indirectly. Indirectly means that there's an indirect way. So then the formula will be S2 is equal to distance of the bird from the boundary B plus C by, this is very important, because for F dash the image formed by the mirror will be F dash. What is F dash? F dash is the image formed by mirror. This F dash is what will be visualized by the bird. So real depth is B plus C. Apparent depth will become B plus C by 1. Okay, similarly, we'll go for next part. Bird as seen by the fish directly. Let me keep this a reference diagram. Let me not disturb that. No. Bird as seen by fish directly. I think this will be much easier. Directly means the rays emitted by the bird will undergo refraction. After refraction, will enter into eye. So it will appear further. We know it. So this will be equal to B minus C is the distance plus mu. Fish is at what distance from the boundary B minus C? What is apparent? What is the real height? A. Apparent height mu A. Next, the rays emitted indirectly. The rays emitted by the bird first will undergo refraction, then will enter into the, will strike the mirror, then the mirror will form the image, and that image will be seen by the fish. So now, first what will happen? Look at the image formed by the mirror due to the bird. That has to be there. No? So the mirror is some sort of like observer. Mirror is observer, which will view the bird. Bird, what happen? Where do it appear? It will appear like at a distance B plus mu A, and that image will be formed. I should give diagram. Huh? It will be very easy for you to understand. Fourth one, indirectly. first bird will be there. This is still bird 1. This distance is A. This is B. The fish is here. First, the bird will appear here, no? B dash. So, what is this distance will be mu A. Then, corresponding to B dash, image will be formed. At what distance it will be mu A plus B. B double dash. This is B. For the mirror, the bird will appear at B dash and that image will be formed here. So why you are doing in this way? Why you are doing in this way? The fish is here. It will see the bird. Bird is at a distance, you know. The mirror is in denser medium and it will first view the bird. There's an idea. See, the rays emitted by the bird first will undergo refraction. The rays emitted by the bird will first undergo refraction, then will fall on the mirror, then will be incident on the mirror. So therefore, the bird will appear further, so mu a. Then its image will be formed. So what is the object distance? Mu a plus b will be object distance. Image distance should be mu a plus b. Okay, agree this. So after reflection from the mirror, it will fall into the fish eye. It will fall into the fish eye. So where definitely what happens for the fish, where do it will appear? The rays, say it is like this, so the rays emitted by a bird will undergo refraction, will fall. So after reflection, they'll enter into fish eye. So therefore, the distance will be C plus mu A plus B. This will be the distance. So this is now omni images. Actually, the fish will see that of the bird, two images. Omni images, the bird will see that of two images. One direct, other due to indirect here. This once again I'll put it here. The apparent height, will be mu A. So at what distance corresponding to B dash, B double dash is the image. This is the object distance. So image distance should be how much it is mu A plus B. So the fish what happen will finally see this particular object like image at a distance how much C plus mu A plus B. Okay, fine. This is one problem. So complete description. Let me show it. Yeah, fine. So what we do is like, I will take out this video. First, fish as seen by bird directly. The rays emitted by fish after refraction will enter into bird and the fish will appear at a distance how much? A plus B minus C by mu. This you know. Fish as seen by the bird directly. The rays emitted by fish will first strike the mirror, then refraction, then it will enter bird. This is the thing. So first there's object distance, so image will be formed at C. Then this f dash will appear at a depth of b plus c. So what is the real depth? B plus c. Apparent depth B plus c by mu. The bird is at a distance a. This is the indirect. So how many images of the fish as seen by the bird? The bird will see two fishes, two images of fish. So finally, what is the conclusion? The bird sees Let's similarly come for this one. Bird as seen by fish. That rays, the rays after refraction will enter into fish eye, so it will appear further. So B minus C plus mu A. Then bird as seen by fish indirectly. First, the rays emitted by the bird will undergo refraction, will appear at a height mu A. Then this particular thing then will undergo reflection. So therefore, so what is the object distance mu A plus B? So image will be formed B double dash. Then the fish will see it at a distance of C plus mu A B. So how many images the fish will see of the bird? Okay, now find the velocity of bird as seen by fish in this one. So we have here the the water level is decreasing. How water level decreases? We have here from here the water will rush. There's a hole is there, so due to this hole, the water level will fall. Now the bird and fish they are at rest. The water level in tank in vessel decreases continuously. This is the idea. What about the velocities that one? Why do they'll be moving first of all? They should be bird and fish they are at rest. No? So we'll do one thing. We will make some assumptions. Let this be y. Then first the positions we'll see this one. The first part. This one will write it. At what distance the fish will appear for the bird? Bird, no? Okay, at what distance the bird will appear? It will be like a y plus mu x. What is y? Y is the distance of the fish from the boundary. Okay, y is the distance of the fish from the boundary. The bird is at a distance x from the boundary, so it will appear further, no? Apparent height. Then look at this one. X and y are varying. X and y are varying. So y is decreasing, x is increasing. So we'll differentiate this one. ds1 by dt is equal to dy by dt plus mu into dx by dt. ds1 by dt, this was the speed, d1 all right. dy by dt minus 2 plus mu 4 by 3 dx by dt. It's a plus 2 minus 2 plus 8 by 3 2 by 3 centimeter per second. What is this? Uh, Speed of the bird as seen by fish. Any distance decreases dx by dt negative, speed negative, distance increases dy by dt positive. Similarly, S2 is equal to Distance of the fish as seen by the bird will be x plus y by mu. So this v2 is equal to dx by dt. This will be positive plus 2, 4 by 3, dy by dt minus 2. What is this v2? Speed of fish as seen by bird. Okay, fine. So this will be our answer, sir. Like this, if the boundary is moving, we can take help of this particular formula. Okay, let's similarly, we'll explore them. The speed of bird and fish are as shown. Find the speed of bird as seen by fish, find the speed of fish as seen by. Now the boundary is at rest. The level of liquid in the tank remains same. So the boundary is at rest. Now only these two are moving. So again our method will be same. Just now we discussed no, the same thing here. First like S1. Find the speed of bird as seen by fish. The bird will see the fish at a distance, move on. This will differentiate. Plus mu dy by dt. Now look at this one. Y is increasing or decreasing? Y is decreasing, no? Whereas x is also decreasing, so both will be negative. So v1 will be minus of, this will be 2. X and y I'll measure with respect to the boundary, you know. X and y I'll measure with respect to the boundary. Both are decreasing, both will be negative, that one. Okay, fine. So we'll write this one. Both are negative, both are decreasing. Just wait a minute. Okay, I'll do one thing. I'll take some other. We'll take some other this one. This will be a little bit because the next problem. Let me use this one because I should take reference as. Yeah, fine. Let me explain by a simple method. Okay, now this will also. I will rewrite everything. Let me. First one. S1 will be at what distance the fish is, find the speed of bird as seen by fish. At what distance the fish is from the boundary z minus x. Plus at what distance real height of the bird is how much? Y minus z. It will appear mu times. What is the distance of the fish from the boundary? Z minus x. Agreed. No? This one. Then what is the height of the bird from the boundary? Y minus z. Since this is in rarer medium, this is a denser medium. So the bird will appear further, no, mu times. This will differentiate. Z is a constant. Z dot or dz by dt is 0. The reason for that, level of water is constant. Okay, this one. So this is v1. 0 minus. Is its speed increasing or decreasing? It is increasing here, no? So what is x dash? This will be plus 2. X is increasing. If x increases, I'm taking the bottom of vessel as reference. So x increasing, it should be positive. Plus dot y. So dy by decreasing. So it will be minus 4 v1 equal to minus 2. So 2 3 just 6 6 minus 22 by 3. X increasing, it should be positive. Okay, this will be the speed of the bird as seen by the fish. Okay, now similarly, we take the next one. Uh, S2 is equal to, regarding the fish, it will be y minus z plus v2 equal to dy by dz, dy by dt. This will be minus 4 dz by dt. This will be 0. Dx by dt will be plus 2 by mu 4 by 3 minus 4 minus 3 by 2. This is speed. Okay, fine. Where the boundaries also is in motion, where the water in the container decreases as shown. So here the water will flow out. This is a hole. The speed of bird and fish are as shown. The water in container decreases as shown. 1 centimeter per second. The bird is moving. Fish is moving up. Find the speed of bird as seen by fish. Find the speed of fish as seen by the bird. One by one, I'll take it. Find the speed of bird. First, for this, what we do is we'll go for z. This is z. This x. This distance of the bird, let it be y. Okay, now distance of the bird as seen by the fish. At what distance the fish is from the boundary? Z minus x. The same method. Then at what is the height of the bird from the boundary? Y minus z. Then apparent height, mu times. The fish is at a distance z minus x from the boundary. What is the actual height of the bird? Y minus z. Apparent height, mu times of y minus z. This will differentiate. Z dot will be minus 1. X, this will be plus 2. 4 by 3. Refractive index of water, this is 4 by 3. Y dot dy by dt will be negative. This will be minus 1. See, as the bird approaches, the y will decrease. Now, all the distances are measured with respect to bottom of container. I am taking this as reference. So, this will become minus 1, minus 2, minus 3, minus 5, minus 20 by 3. Oh, sorry, calculation minus 3. Yeah. Minus 4 plus 1 will be minus 3. Minus 3, 3 get cancelled, so minus 4, so minus 7 centimeter per second. This will be our answer. Now, find the speed of fish as seen by the bird. This will be S2 is equal to, what is the actual depth of the fish? Z minus X. Hmm? Bird at what distance is there from the boundary? Y minus Z. Bird is at a distance of Y minus Z. Then what is the actual depth of the fish? Z minus X. Real depth, the apparent depth will be. What is Y minus Z? Y minus Z is distance of the bird from the boundary. Y minus Z. Real depth of the fish is Z minus X. Apparent depth Z minus X by 1. This will differentiate. Y dot, this will be minus 4. Z dot minus 1. X dot plus 2. 4 by 3. So minus 4 plus 1 will be minus 3. Minus 1, minus 2, minus 3, minus 9 by 4. I think I'm doing properly the calculations. Minus 1, minus 2, minus 3. This 3 will come to the numerator. So minus 9 by 4. So 4 3 are 12. 12 plus 9, 21. So minus 21 by 4. This is the speed of the bird as seen by the fish. I'm bringing all the conditions one by one. Huh? We'll go for, please make observation. This will be moving, mirrored, and the level of water is also changed. Find the number of images, position, and speed of fish as seen by bird, bird as seen by fish. Now, there's a bird at a height A, level of water, this is B, fish is at a distance C, this is silvered, bottom of vessel is silvered, bottom of vessel is silvered, and level of water in vessel decreases. Okay, first we'll speed of as seen by bird directly. Speed of fish as seen by bird directly. The fish is at a depth B minus C. The fish is at a depth B minus C. At what height the bird is at a distance C. First we'll calculate the distances. S1 is equal to, at what distance the bird is from the boundary at a distance C. What is the real depth of the fish? B minus C. Apparent depth. So therefore the distances will be, what do you mean by dot? Derivative, that one. The first order derivative will write like this. Suppose if I write y dot, it is nothing but dy by dt. Okay, fine. To save time, I could have written dy by dt, dA by dt, dB by dt, dC by dt. So we are just writing dot here. The first order derivative we just indicate by dot here. So this will be v1. Now dA by dt, dA by dt. Oh, so, okay, that is, I should take all the references. Sorry, some correction is there. All the distances. So this is a reference for us. Definitely, this will also change. I'll bring it again. Huh? Okay, what distance the bird is from the bottom of the vessel? A. What is the depth? What is the level of water in the vessel? B. At what distance the fish is from the vessel, bottom of the vessel? Let it be C. Now, distance of the bird from the boundary, A minus B. Real depth of the fish, B minus C. Apparent depth, B. What about this? What I'm discussing, the rays emitted by fish will undergo refraction, will enter into bird. That's what directly, huh? No, this will be varying. So V1 equal to dA by dt minus 5. dB by dt minus 2. dB by dt minus 2. dC by dt solving this minus 5 plus 2. This will be minus 2, minus 2, minus 2, minus 4, minus 4. This will get cancelled. So this will become, will end up with only minus 3. Minus 5 plus 2 will be minus 3, minus 3, minus 3, minus 6. So minus 6 centimeter per second. Next, speed of fish as seen by bird indirectly. Yeah? So the rays emitted by fish, first it will strike the mirror, it will form an image. Already we have discussed one problem, I need not to repeat here. Then that image will be seen by the bird. So it will be S2 is equal to first the distance of the bird from the boundary A minus B. Then the fish will is at a distance C. First the rays emitted by fish will strike the mirror. It will form image F dash, and the rays reflected by the mirror will undergo refraction, will pass through the bird. So this everything will appear like a liquid for us. So therefore this will be uh, so how much we should write? B plus C by mu. Already I discussed. Okay, this will be V2 equal to dA by dt minus 5, dB by dt minus 2, dB by dt minus 2, dC by dt plus 2, 4 by 3. Minus 5 plus 2 minus 3, minus 2 plus 2, this will be 0. Okay, this will be the speed of fish as seen by the bird indirectly. Now we'll go for the bird one. Let me finish off this problem here only. Second, third one. Speed of bird as seen by fish. S3 is equal to speed of bird as seen by fish directly. As seen by fish directly. So at what distance the bird is? At a minus B from the boundary. At what distance the fish is from the boundary? B minus C. So this will become mu times of A minus B. Differentiating this, minus 2 plus 2, mu is how much? 4 by 3, minus 5, B is how much? Minus 2. Yes, sir. How you are writing all this? B dot as the level of liquid falls, so it should be minus 2, no? B will be B dot, rate of change of dB by dt will be negative. The distance C increases, so dC by dt of C dot should be positive. dA by dt, A decreases. As the bird moves, A will decrease. So therefore, dA by dt will be negative. Level of liquid falls, dB by dt negative. Whereas dC by dt will be positive. So where all B dot is there negative, C dot will be positive. This will solve it. Minus 4 V3 equal to, this will be minus 4, minus 5 plus 2, minus 3, minus 4, minus 4, minus 4, minus 8. Okay, speed of bird as seen by fish indirectly. It will see through the mirror. Huh? Speed of as seen by bird indirectly. S4 is equal to. First, at what distance the fish is from the boundary? B minus C. Indirectly means first what will happen? The bird is at a distance A minus B. The mirror will see the bird, no? And the bird what happen will appear further. The bird will appear further. So what is the distance of the bird from the boundary? A minus B. A minus B is that one. So apparent height will be mu times of A minus B. And that will be seen by the mirror, no? And its image will be formed. So therefore, this will become B minus C, B plus mu times of. Okay, that's also like this one. Okay, I think I'm here like this. The mirror A minus B with the real height, apparent height will be mu times of A minus B. So therefore, this will be C plus B plus. So how you are writing? What is the distance of the fish from the mirror? C. Okay, that one. First, the mirror will form the image of bird, no? And the rays emitted by bird will undergo refraction. So due to that, the real height is A minus B, apparent height will be mu times of A minus B. Then what is the object distance will become mu times of A minus B plus B. This everything is, this will differentiate. C dot, this will be plus 2, B dot minus 2, minus 5, so B4 will be, we'll just do calculation, minus 5 plus 2 will be minus 3, so minus 4, minus 4, minus 6 plus 2, minus 4. I'll make the boundary. I think we have, Okay, I didn't draw the diagram only through, since already we have discussed, so I just explained it. Okay, see once everything. Yeah. Can you hear? I think some voice problem is there. Yeah, cos alpha is 1 by 5, no? 1 by root 5. Okay, I got the value. Now this will become 4 by 3, 1 by root 5. So sine theta will be, everything will change here. I think this is the problem which troubling a lot of calculations, of course. Like, okay, let's proceed here now. So sine theta will be 3 by 4 root 5, that one. We need tan theta, so sine theta will be 4 by root 5. Okay, call this is a sum a. Now this will become 3 square plus a square equal to 4 root 5 whole square. So a square equal to 16 5 ja 80. 80 minus 9. A equal to root 71. Root 71. Let me keep here. Now tan theta I can define it. What is the tan theta? Tan theta will be 3 by a. Tan theta equal to 3 by root 71. Okay, I have all the values. Let's get into the thing, that one. So tan alpha, now this I'll write beta. Tan beta is what we need. Tan alpha we have a value, no? So tan alpha equal to 20 minus h 20 minus h by x2. Tan alpha is how much? 2. Call equation 1. Then tan theta is equal to x1 by h. Tan theta value is needed, which is 3 by root 71 equal to x1 equal to h. So x1 equal to 3h by root 71. And we know x1 plus x2 equal to 5 centimeter. x1 is how much? 3h by root 71 x2 will be 10 minus h by 2 equal to 5. Hope this time I must get answer. Huh? Root 71, 8.43. Three divided by 8.43. 0.3536 plus 0.5. 0.85. So h is equal to 0.85. I have to accommodate everywhere, everything in this year. 5 divided by 0.86. Let's see how much will get it. 5 divided by 0.86. 5.81. Okay, to this height, the liquid has to filled up so that that will be visible. Okay, I think lot of errors, everything was there. Okay, let me summarize again. An eye is positioned at the edge is able to view only the vertical wall AB as shown. So this is alpha. So first the eye is able to visualize only this part. AB is visible. Then this is not visible. Then I'll fill up a water to certain height. Then the midpoint of this should be visible. So the rays emitted by the object O after refraction should enter into the eye. So it will undergo refraction here. Angle of incidence, angle of refraction. Okay, now we'll write it here. Mu sine theta is equal to mu, this is A, no, 1 into sine beta. Solving this, we don't know beta. Beta will be 90 minus alpha. Beta plus alpha is 90. So 90 minus cosine of it will be cos alpha. Then from here we have tan alpha is what? 20 by 10. So we'll get the cos alpha. Substitute cos alpha, we'll get the sine theta. Sine theta, we should calculate tan theta. Then come for here. Tan alpha should be equal to 20 minus h by x2. Solve for x2, we'll get this much here. Then tan theta should be equal to x1 by h. So tan theta should be equal to tan theta value we know 3 root 71. So x1 is equal to 3h by root 71. Okay, then we know x1 plus x2 is equal to, these are some things which we have brought from the looking at the diagram, these things. Then substituting x1 and x2. We have x2 value, x1 value. Substituting these yellow color things, x1, x2 value in this equation, solving for h, we'll get this answer. This is our answer. Okay, I think it took a lot of time. Almost half an hour it took. Somewhere calculations, data wrong all. Let me go for next one. Again, this will be hope. An observer can see through a pinhole the top of a thin rod of eye touch placed as shown. When beaker is filled with a liquid up to a height 2h, he can see the lower end. You can see the lower end of the rod, find the mu of a liquid. Now earlier what happened, only this part is visible. A, B, C. Now what is visible? Without water, only AB was visible. After pouring water, ABC is visible. Empty vessel. I think I should give this diagram. Huh? Now what is visible? Only visible. Now after pouring water, liquid, so some liquid, then ABC is visible. So again, what is the basic general method? If this is the normal, the rays emitted by the bottom of the rod the rod after refraction will enter into the eye. Then is able to see the bottom of the rod. Okay, this is theta 1, this is theta 2. What is theta 2? Now we should calculate this theta 2. Theta 2 should be equal to A, B, C, D, E, F. Theta 2 should be equal to 45 degrees. You can see this. So what is this height? This width is 2h. This is 2h, no? Theta 2 will be 45 degrees. So let me apply Snell's law. Mu theta 2. Mu sine theta 1 is equal to 1 into sine theta 2. Sine theta 1, I should calculate. This should be 1 into 1 by root 2. Sine theta 1 I can calculate from here. 2h, this is h. Now from where this I brought it? From here. Looking at this triangle. This will be 2h. This will be h, no? So sine theta 1. So mu equal to 1 by root 5. This will be your answer. If you fill up with liquid of refractant as root of 5 by 2, even the bottom end of the rod will be visible for us. Okay. Now a ray enters a glass slab at an angle alpha from it, and the refractant index varies along the slab as mu naught minus kt square, where t is the distance measured along the normal. Mu naught and k are constant. The glass slab is sufficiently thick. How far along the normal will the ray go before it reflects back? This is something. So as t increases, the mu will decrease, no? So what's happening to the ray? The ray is moving from, in fact, the ray will move from denser to rarer, so it should bend towards normal. Sir, can you give me the diagram? Okay, let's do one thing. We'll try with the diagram. ray enters a glass slab. Yeah, from here, the ray enters a glass slab at an angle alpha from A. Alpha and theta. Okay, this is again some error. This be theta. This is theta. Then this is the how long. So the ray what will happen will undergo somewhere here. We can go for it. Here the ray is incident almost. It is going to graze. It will be 90 degrees. This angle of incidence will become now 90 degrees. This is a normal. Sir, how you can give the diagram? Because see, it is moving from the t will as t increases, the mu will decrease. So the ray is moving from denser to rarer. First it will bend away from normal. Afterwards it start this one. Okay, this is here. So now what we can write? 1 into sine theta is equal to the refractive index will be at that particular point will be mu naught minus k naught k t naught square into sine 90 degrees. So sine theta equal to mu naught minus k t naught square. So k t naught square equal to mu naught minus sine theta. So t naught equal to mu naught minus sine theta by k. What is that t naught? How far it will go inside the slab. Hmm? We'll take the next one. Similar one more problem. Here we have diagram also. A ray of light enters into a thick glass slab from air as shown in figure. The refractiveness of the glass slab varies with the depth x, where x is slab is sufficient large thickness. Find the maximum depth reached by the ray inside the slab. The similar problem what we discussed. If this is slab, okay, the ray is here. No, it is moving from A. Put x equal to 0, it will have root 3. So it is moving from light to denser. The ray will come here. Then inside the mu varies. So this will be the boundary. But as x increases, the mu will decrease, no? So it will bend away from normal. So therefore the ray will be. Then again. Finally the path of the ray will be. So here. So this will be the 90 degrees. Find the maximum depth reached by the ray. This H is what is asking. Sir, why the path of the ray? Okay, of course, first it will move from light to denser, it will bend towards normal. Then afterwards, you see that one, as it moves, the mu will increase. Sorry, mu will decrease. So it is moving from denser to rarer, should bend away from normal. So this angle of refraction should keep on increase here. So finally, at one particular point, the angle of incidence is such that it will just graze the boundary here. So there is a maximum depth. Afterwards, the path of the ray will be something like this here. This h has to be determined. So applying this sine 1 into sine 60 equal to mu into sine 90 degrees. So root 3 by 2, mu is how much? Root 3 minus x by root 3, sine 90 is 1. Solving for x will get the required answer. Root 3 by 2, x by, so maximum depth how much it will be? 1.5 meter. Yes, next one, a circular beam of light of diameter 2 centimeter falls on a plane surface of glass. The angle of incidence and mu equal to the diameter of the refracted beam is. I think we must have a diagram. There's a boundary. Okay, the ray will be incident. Okay, the ray will be incident. Parallel to it, do it like this. This is the this is actually the diameter. After refraction, let me use some other color. It will be like this. Then this will be the perpendicular. Okay, I think I'll give all the things. This is the 60 degrees. This is air. This is the glass. I think I'll make still more clearer. Okay, fine. This will be. So this angle 60 degrees. This will be diameter D. This is what is asking. Cal. You have to calculate the diameter in glass. Hope everyone is able to understand. In glass, the diameter will be this much only. You must understand the diagram. Rest all mathematics, nothing is there. So what will be the diameter? Capital D will be diameter in glass, in air it is D. So this D has to be small, capital D has to be calculated. So this angle will be 60 degrees. This will be mu G. This will be mu A, which is equal to 1. Okay, this will be P, Q. This will be perpendicular. What is this? This is the angle of refraction. R. This is R. So applying Snell's law, sine 60 mu A sine 60 should be equal to mu G into cos R. 1 root 3 by 2, 3 by 2 cos R. So what is cos R equal to 1 by root 3. This angle should be R. Then from the triangle, from triangle PMQ, from the triangle PMQ, cos R, should be equal to MQ by PQ. Again, from the triangle PQ, okay, this is R, I write it. From triangle PRQ, what we can write it as sine 60 is equal to cos 60 is equal to, sorry, cos 60 is equal to PR by PQ. So PQ 1 by 2 equal to PR. PR is D by PQ. So PQ equal to D. Let me substitute here. Cos R is 1 by root 3. MQ is equal to D. No? I'll substitute these things here. PQ equal to D, cos R equal to 1 by root 3. These things in this equation. 1 by root 3. B equal to how much? 2 centimeter. So 4 by root 3. So root 3 is how much? 1.73. 4 divided by 1.73. 4 divided by 1.73. 2.31. Okay, this will be our answer. Okay, very simple. So what is capital D? Diameter of the refracted beam. That we have to calculate. Find the value of D. It's very hot here. Three more problems are there. Let me finish off this one. Yeah. A ray of light is moving. A ray of light is moving along the unit vector I cap minus 2 j cap, undergoes refraction at an interface of two media, which is the exact plane. The refractive index for y greater than 0 is 2, while for y less than 5 root 2. Find the unit vector along with the refracted ray moves. We are just discussing Snell's law, vector form of the Snell's law. Just a small problem. It's a vector form of Snell's law here. First unit vector along the unit vector I cap minus 2 j cap. So we should, what is the thing is needed, like first there is a boundary. Which is the exact plane. The refractive index for y greater than 0. Y greater than 0 is 2, while for y less than 0 it will be this one. So this will be y axis, I'll take it. The refractive index of this is 2. Y less than, okay, sorry, this will be root 5 by 2. Mu1, let this be 2. Now the ray is incident. undergo refraction. Okay, fine. We have to calculate the sine theta 1. We know there's a unit vector. So how to calculate the unit vector? Sine theta 1 is needed. First we'll calculate the vector here, unit vector along that one. So I cap minus 2j cap by root 5. This is the unit vector. Vector by magnitude will be unit vector. Cos theta 1 is equal to this is a vector j cap by mod of a I think let me read. Yeah, fine, fine. This will be a bar minus a bar. This will be vector by its magnitude will be unit vector. Vector it is. So unit vector will be given by this particular thing. Vector by its magnitude will be unit vector. So angle made by this with y-axis is needed. So I'll take this particular form. So this will become I cap minus 2j cap dot j cap. Mod of this will be root 5. Mod of unit vector will be 1. Magnitude of unit vector will be 1. So solving this, I dot j, so minus 2 by root 5 will come. This is cos theta 1. So what is sine theta 1? One by root 5. So applying the Snell's law, mu1 sine theta 1 is equal to mu2 sine theta 2. Mu1 is how much? 2. Sine theta 1 is 1 by root 5. Mu2 is how much? Root 5 by 2 sine theta 2. So sine theta 2 equal to 4 by 5, which is nothing but theta 2, 53 degrees. So now you should find the unit vector along with the refracted ray moves. So what is r cap? R cap is equal to sine 53 degrees high cap minus cos 53 degrees j cap. So 4 I cap by 5 minus 3 j cap by 5. So this is a unit vector along which refracted ray will be directed. Okay. Okay, the next one. Here there's a mirror, spherical mirror. So what is showing this object is there. An object is placed at the bottom of the tank on axis convex. If image of is formed at 25 cm below the surface of the liquid. It's somewhere here, the final image will be formed. Find the focal length of the mirror. So 15 centimeter. Tank of height how much? 32.25 centimeter. Okay, what this particular layer of liquid will do is first the rays emitted by it will undergo refraction and will reach here. No? So you can take this to be the apparent depth. So first where do O dash will appear? O dash will appear here. So how to will take this is P1, let this be P2. So P1 O dash should be equal to P1 O by mu. P1 O is how much? 32.25 by, this will be 4 by 3. So this will be the P1O, P1O dash, apparent depth of that one. Somewhere the object, this particular mirror will see that that object is at real depth here. This will be the apparent depth, P1O dash. This will calculate here. Let me take help of calculator. 3 into 32.25. 96.75. 96.75 by 4. 24.81. 24.1875. Okay, after refraction, the rays will be incident on this one. So then we'll apply the mirror formula 1 by P1 I1 plus 1 by P1 O dash. O1, I'll write it a symbol. One by so this P1 I1. Find the focal length of the mirror is telling. Okay, P1 O1 is how much we know, 24 minus this we don't know. But what is the condition given? The final image will be formed. The final image will be formed at a depth of 25 centimeter below the surface. Final image is telling. Final image is here. So how to bring that intermediate one? Where is the I1 will be? Are you getting now? We need focal length. For this, we don't know. We don't know these two here, but we know final image. Huh? So what actually happens? The rays after refraction will be, and the final image and the I1 will be somewhere here. I1, I'll bring it here. So the rays wants to converge here. So this will be like a virtual object will be pushed further, no? So here we'll write it here. Pi should be equal to mu times of P1 I1. Pi we know. Pi is how much? 25. 4 by 3. P1 I1. So 75 by 4. This I'll substitute here. 1 by 70 by 4 equal to. Solving this, we'll get the focal length. Okay, this one. I'll give the answer. I just calculated it. Uh, Let me check the answer and tell you the answer also. I'm having the answer. Always better to work out. 20 centimeter. Check it out. So we have not understood this particular thing. So first the rays will undergo refraction, then a, from as if from O1 they'll fall on the mirror. Then it will form the image I1. After reflection open, the rays wants to converge at I1, but again they'll undergo refraction, they'll converge at I. So I1 will become like virtual object. So the real depth will be P1I, P1I, P1I should be equal to mu times of P1I1. Okay, this will be the last problem. I'm also very tired. Is asking to calculate the angular velocity of the incident ray. So applying Snell's law. Differentiating this cos theta 1 equal to d theta 1 by dt. Mu 1. And the angular velocity of refracted ray. Omega 1 is the angular velocity of incident ray. Omega 2 will be the angular velocity of the refracted ray, that one. So that has to be calculated. So how do, what is theta 1, theta 2? We assumed it, no? In fact, so I can write it here, no? Mu 1, cos theta 1, let as it is. Cos theta 2, I can write it as mu 1 omega 1 cos theta 1 equal to mu 2 1 minus sin square theta 2, I'll write it as mu 1 square sin square theta 1 by that will cancel. So mu 1 omega 1 cos theta 1 is equal to what is the direction of this? It will be like this. Okay. Kids, like we had the discussion, some almost I think some more calculation based things came. So I also went to some found difficult in calculations. A little bit I'm tired also. Hmm? Okay, fine. Try to work out some numericals related to few more numericals here and there in books are available. So try to solve them. Hmm? So almost I think plenty of numericals I explained in the refraction at plane surface. So make use of them, think on them, understand it, learn it, and try to solve more number of numericals. You get still more clarity. Okay, thank you all of you. I'll end up the class. We'll meet again in the next topic. Okay, bye. See you all of you. Take care.